everybody, and welcome back to your Task 4.9 video. We have one learning target for today, and that learning target is I can use inverse operations to solve inequalities in one variable. Now, what we're going to be working on today is solving inequalities, just like we worked on solving equations. And the good news is that solving inequalities is exactly the same thing as solving equations, with one exception. So the only exception, and this is important, is that when you, in the process of solving, multiply or divide by a negative number, you need to flip the inequality symbol. Now, here's what I mean by flip. If you started with a greater than, then that's going to become a less than. If you started with a less than, that's going to become a greater than. If you started with a greater than or equal to, that's going to become a less than or equal to. And if you started with a less than or equal to, that's going to become a greater than or equal to. You're literally just going to flip them over. I call this the flip-flop rule. Now, one thing that I want to point out is that we do not do this all the time. The only time you flip your symbol is when you multiply or divide by a negative number. So if you're just multiplying or dividing by a positive number, you don't flip. If you're just multiplying or dividing by a negative number, if you're just multiplying or dividing by a positive number, you don't flip. If you're adding or subtracting with a negative number, you don't flip. It's only when you're multiplying or dividing specifically by a negative number. Now, our directions here are going to be to solve and graph. And by solve and graph, I mean find the answer and then graph that answer on a number line. So we're going to review in a second when we go to make our graph when we use an open or a closed circle. So let's take a look here. If I want to solve this, I'm going to start the same way I solve my equations, which is to draw a vertical line through the inequality symbol. In this case, it's a little bit different because it's an inequality symbol and not an equals, but it's the same idea. Now I want to get all of my x's together on one side. So the first thing I'm going to do here is subtract x on both sides of that line. Now on the left side, I'm just going to drop down the 5, and negative 3x minus another x would be negative 4x. I'm still going to have my less than or equal to symbol here, and on this side, the x's are going to cancel, so all I have left is 13. Now I'm going to try to get x alone. So I'm going to start by subtracting 5 on both sides. When I do that, I'm going to get on the left side, the 5 and the minus 5 cancel, and so I just have negative 4x. And then I have my less than or equal to, and 13 minus 5 is 8. Last but not least, I need to divide by negative 4. Now, what you'll notice is that I'm dividing by a negative number here. So on the left side, the negative 4 cancels the negative 4, and we just have x. On the right side, 8 divided by negative 4 is negative 2. But because we divided by a negative, we need to flip the inequality symbol. So what used to be a less than or equal to is going to become a greater than or equal to. Now, when I go to graph my solution, important things to remember are you're going to use an open circle whenever there's a greater than or a less than. You're going to use a closed circle whenever there is a greater than or equal to or a less than or equal to. On a number line here, to graph x is greater than or equal to negative 2. The important number here would be the negative 2. I would want one number that's bigger, so negative 1, and one number that's smaller, so negative 3. I'm going to use a closed circle on the negative 2 because it's a greater than or equal to, and then I'm going to shade to the right because it's a greater than. Now, if you forgot to flip your symbol, then instead of shading to the right, you would have ended up shading to the left. So you'd have the wrong numbers as part of your solution set. The correct numbers here are going to be the numbers that are bigger than or equal to -2. If you forgot to flip, you would have thought that your correct solution set were the numbers that are less than or equal to -2, so the opposite. What we're going to do now is just practice solving a whole bunch of times. So for problem number 1, we're going to go ahead and start by drawing a vertical line through our equal sign. Now, in order to solve this, we just want to get x by itself. The only thing that I need to do here is divide by -4 on both sides. Now, when I divide, I get x and I get -2. But because I divided by a negative, we need to flip the symbol. So I divided by a negative. Therefore, I need to flip the symbol. So instead of less than or equal to, my solution is going to be greater than or equal to. So on my inequality line here for my solution, I'm going to write x is greater than or equal to -2. Now, if I think about my interval notation, it's oftentimes easier to figure that out after you have your graph. So the first thing I would do is I would put a closed circle on the -2 because it's a greater than or equal to, and then I would shade to the right because greater than means go to the right. For my interval, I can see better now that my first number would be -2 and my end would be infinity, and I would use a bracket and a parentheses. For problem number 2, my goal again is to get the m in this case by itself. In order to do that, I'm going to subtract 2 on both sides of the line. And that means that I get m and I get -3. In this case, since we did not multiply or divide by an inequality, there is no need to flip the symbol. So this would still just be a less than or equal to. Now, as a general rule, I don't want my variable to be on the right-hand side. I want my variable to be on the left-hand side. So all I'm going to do is I'm going to switch the order here, and I'm going to write m is greater than or equal to -3 as my final solution. Now, the reason I might want to do that is because it makes it much easier to graph. So greater than or equal to -3 means a closed circle on the -3, shade to the right. My interval symbol or my interval notation is going to be -3 comma infinity. And then I'm going to use a bracket because it's a closed circle and a parentheses. Now for problem number 3, if I want to solve this, I'm going to start by drawing a vertical line through my equal sign. My first step here is going to be to divide by 2 on both sides. Now this time I am dividing, but I'm not dividing by a negative number. So there's no need to flip the inequality. It's still just going to be less than or equal to. And 4 divided by 2 is 2. Next, I'm going to add 5 on both sides. And when I do that, I get x and then less than or equal to 7. So that's going to be my solution, is that x is less than or equal to 7. Now on my number line, I'm going to find the number 7 and put a closed circle, and I'm going to shade to the left because x is less than or equal to 7, which means if I remember that negative infinity is on the left side, my interval notation will be -infinity comma 7, and I'm going to put a parentheses and put a bracket because it's a closed circle. For problem number 4, I'm going to go ahead and draw a vertical line through my equal sign. Now, in this case, I'm going to start by dividing by -3/4 on both sides. This time, I am dividing by a negative number. So I'm going to get x minus 2 on the left, and 6 divided by -3/4 makes -8, so I'm going to get -8 on the right. But this time, I'm going to flip the symbol because I'm dividing by a negative. So this is going to become a greater than instead of the less than that I originally started with. Now, x is still not by itself, so I'm going to go ahead and add 2 next. and I'm going to get x is greater than -8 plus 2, which is -6. Now that means my solution is all of the numbers that are greater than -6, x is greater than -6. On a number line, I would have an open circle on the -6, and I would shade to the right. And my interval notation would be -6 comma infinity with a parentheses by both because there's an open circle and an infinity. We're going to do a few more examples here. So for problem number 5, in order to solve this, I would start by drawing a vertical line through my equal sign. Now I want to get x by itself, so the first thing that I would do is I would subtract 2 on both sides of the inequality, and that's going to give me -7x is less than -5 minus 2 is -7. Next, I'm going to divide by -7 on both sides. Now this time I'm dividing by a negative. So when you divide by a negative, you're going to need to remember to flip the inequality, which means -7 divided by -7 makes 1, and we're going to change our symbol to a greater than symbol. That means that my solution would be x is greater than 1. On a number line, I would put an open circle on the 1 and shade to the right. And that means that my interval notation would be 1 comma infinity, and I'm going to have a parentheses by both because there's an open circle and an infinity is always a parentheses. For problem number 6, I'm going to start by drawing a vertical line through my equal sign. Now in this case, I've got x's on both sides, so I'm going to go ahead and subtract the 2x on both sides to get the x's together. When I do that, 6x minus 2x is 4x, and the 2x's cancel over here. I'm just going to drop down the -7 and the greater than and the 17. Next, I'm going to add 7 on both sides. So that gives me 4x is greater than 17 plus 7, which is 24. And then we're going to divide by 4 on both sides. Now this time I am dividing, but I'm dividing by a positive number, so I don't need to flip anything. So x would be greater than 6, and that's my inequality solution. For my interval, I often find it easier if we make the graph first. So I'm going to go ahead and put an open circle on the 6 and shade to the right. And then that means that my interval would be from 6 to infinity, and I'm going to use a parentheses for both because it's an open circle and an infinity. Next, for number 7, I'm going to start by drawing a vertical line through my inequality symbol. Now, in this case, the first thing that I'm going to do is think about dividing by 2. However, the 9 and the 27 are not divisible by 2. So what I'm going to do instead is I'm going to go ahead and distribute the 2, which means I get 2x plus 6, and then I'm going to have that is greater than 9x plus 27. Next, I'm going to get the x's together, so I'm going to subtract 9x on both sides. And that is going to give me -7x plus 6 is greater than 27. Next, I'm going to subtract the 6 on both sides. So that's going to give me -7x is greater than 27 minus 6, which is 21. And last but not least, I'm going to divide by -7. Now, in this case, I am dividing, and I'm dividing by a negative number. So I would get x and -3, and I'm going to flip the symbol because when you divide by a negative number, you need to flip the symbol. So my solution is x is less than -3. Now on a number line, I'm going to find the -3, put an open circle, and shade to the left, which means if I remember that negative infinity is all the way to the left, my interval notation would be -infinity, comma -3, and I'm going to use a parentheses for both because it's an infinity and an open circle. Last but not least, for number 8, I would draw a vertical line through my inequality. Now I'm going to add 7 on both sides. And that means that I have 2x over 3 is less than or equal to negative 5 plus 7, which is 2. Next, I'm going to undo the divide by 3 by multiplying by 3 on both sides, which means I get 2x is less than or equal to 2 times 3 is 6. And last but not least, I'm going to divide by 2, which means I get x is less than or equal to 6 divided by 2, which is 3. On a number line, that means I would put a closed circle on the number 3 because this time we can be equal to the number 3 and shade to the left because it's a less than or equal to symbol, which means if I remember that the number line on the left side is negative infinity, I would have negative infinity, comma 3, and I would put a parentheses here and a bracket here because that is a closed circle. All right, as you can see, solving an equation is very similar to solving an inequality, so we can use a lot of the same tools and techniques that we've learned before in order to solve these problems. The only new thing is that when you multiply or divide by a negative, you need to make sure to flip the inequality symbol. Thank you all so much for watching, and I'll see you soon for some practice.